going on, everyone? I am DB, and what's a for loop? What's a for loop? What's a for loop?
What's a for loop?
So let's go ahead and open our Java folder with our IDE. So I'm going to go ahead and open mine with Visual Studio Code. Let's go ahead and make a new file. We're going to click the new file button in the top left corner, and we're going to call this file for.java. And let's make a class inside of our file. We're going to call this class for, and we're going to do an open and close curly bracket. Now let's go ahead and make our main method. If you've ever made one before, go ahead and say it with me. Public static void main string array args, and let's get into it. So before we write any code, let's talk about what a for loop is and what it's used for. A for loop is a loop that allows you to execute code within a particular block, and we'll show you what that block is in a little bit. When do you want to use a for loop? Typically when you know how many times that you want to loop. Now that's not always the case, and you can definitely use for loops differently, but most commonly you're going to use a for loop when you know how many times that you want to loop. So let's go ahead and take a look at the basic anatomy of a for loop. The way a for loop typically breaks down is like this. For, open and close parentheses, and then an open and close bracket after the parentheses. And then everything that you want to loop over is going to be between these brackets that we created. So any code that you put between those curly brackets is going to get looped over. But what controls how many times we loop? That's where these parentheses come into play. And typically, for a for loop, there's three things that we have to consider when we're putting in the parentheses. I'm going to go ahead and take some notes by using comments. So let's go ahead and do 2 slashes. And let's start with the first element inside the parentheses, which I like to call the control. The control is simply a variable that allows you to control the loop. When you're looping through, the control is going to be the variable that gets incremented or increased or decreased in order to control when the loop stops. But in order to detect when the loop stops, that's where we get to the second element of the for loop, which I like to call the check. The check basically is a check to see if conditions hold true to continue the loop. So if the check is ever false, you exit the loop. And the important thing to know about the check is the check will always come first before the loop executes. So that way, if the check fails, then you just won't execute the code. And don't worry, you'll see an example of this in a little bit. The next and the final part that I want to talk about is what I like to call the increment. And this just basically controls how fast you go through the loop. So let's take a look at what these three things look like together. So first, let's do our control. So we're going to make a variable. I'm going to call this int I equals 0. Next, whenever we want to separate the control, the check, and the increment, the way we do that is by a semicolon. So I'm going to go ahead and put a semicolon here to end the control. Now let's do the check. So let's check to see if something like, so since we're dealing with I as an integer value, let's just say something like I is less than 10. And then the last thing, let's go ahead and put our little separator with our semicolon. The last thing is our increment. Now in Java, one way to increment is simply by saying I++. So I++ is the same thing as saying I is equal to I plus 1. So let's go ahead and write that down as a quick note just in case. I++ is equivalent to I equals I plus 1. So I equals I plus 1, just as an example, if I was 1, I plus 1 would be 2. And then if I is 2, I plus 1 would be 3. So you see how it would kind of increment one at a time? I++ does the exact same thing. So let's kind of test that out. Let's take a look to see what happens if we print out I. So let's go ahead and do a system.out.print. So we'll say system.out.println, and then we'll simply just print I. So we're going to go ahead and save this. Let's go ahead and open up a terminal. So I'm going to go ahead and click that, and I'm going to go to my desktop and my Java folder, and we're going to compile with Java C, and then we're going to do for.java. Looks like we didn't get an error. So now let's go ahead and run it by typing Java 4. And as you can see, we got some numbers that printed out, but it looks like 10 didn't print out. Let's make sure we understand why. So if we go back to our for loop, we see that I starts at 0. So it totally makes sense that 0 is going to print as the first number. But the reason why 10 doesn't print, remember, we said I is less than 10. So the last time I is less than 10 is true is when I is 9. So if we go back and look at this, that's why 9 prints and 10 doesn't print. So do you see how the for loop does a check before it runs the code block here? So, and just a reminder, only things between the curly brackets are going to execute in the repeat of the loop. So basically, once this hits 10, once I hits 10, the code will resume after this last curly bracket. That's one basic for loop that we could do. But let's kind of look at how we can change this. So one other thing we could do, instead of incrementing by plus plus, remember how we were saying that we could say I is equal to I plus 1? Well, that's definitely another way to write it. But what if we wanted to increment by 2 instead? Well, then we could do something like I equals I plus 2. So then that way, when we increment, we'll go up 0, 2, 4, and so on and so forth. So let's go ahead and save this, and let's go ahead and give it a run. So we're going to compile, and then we're going to run this. And now you can see we got 0, 2, 4, 6, and 8. So that's another cool little way that you can make this change. But now let me show you a way that you can actually get into trouble. So let's do something slightly different. So we just added 2, but what if we wanted to multiply by 2 every time? Let me go ahead and make this change. And I'm not going to change anything else with this code, but I want to let you know ahead of time it's going to break. Pause the video and think about how this could break based on how the code is currently structured. Once you've made your guess, go ahead and play it from here, and let's go ahead and see what happens. So if I compile this code and I go ahead and run the code, so let's go ahead and do Java 4. Look at all those zeros that are printing. In fact, if you look over here, you can see this is still running. What I have just done is I've created what's called an infinite loop. And the reason why it's infinite is because 2 times 0 will always be 0. And no matter how many times I go through the loop, if I say I is equal to 2 times 0, I'm always going to have I equal to 0. And therefore, I can never exit the loop, because if I is always 0, I will always be less than 10. Therefore, infinite loop. So let's go ahead and open our terminal back up, and I'm going to hold down Control and push the letter C as in cat to cancel. And that way my infinite loop cancels because it's going to use up resources on my computer. So let's go ahead now and come back here. So that's one way that you can get into trouble with this. And just remember that each way in each one of these 3, the way you make changes absolutely matters to how this will function. So you saw how a small change here broke that. Well, a small change on the control will fix it. So instead of I being 0, if I was 1 and we saved this and we re-executed it, so let's go ahead and compile and run, we can see we got 1, 2, 4, and 8. And actually, it's going to increase by 2 every single time. So the next time would be 16, the next time would be 32, and then 64, and so on and so forth. Basically, what we did is we increased by a power of 2, and that's how we could do a power of 2 here. That's one cool little change that you can make to the increment to make things move through in a different way. So now let's go ahead and set this back to I++. And the next thing I want to talk about is actually setting these to variables. So you notice how they're both fixed. So right now I say I is equal to 1 and I is less than 10. Well, what if we wanted to rely on a variable in order to set what our ending condition is? We absolutely can. There's nothing to stop us from doing that. So what I can do here, let's go ahead and make a variable. I'm going to say int, and this is going to be classroom size. So we'll say class size is equal to 30, saying that we have 30 students. So instead of saying I is less than 10, what I could say is I is less than class size. And now I'm checking against a variable to see if my loop can exit. So now that we're checking against a variable, our exit condition can change, which means that one run, this might be 30, but on the next run, it could be 142, because if we decide to change class size, then the loop will change to match the ending of the variable. So let's go ahead and run this and see what happens. So I'm going to go ahead and compile, and then let's run it. And now you can see we got 1 through 29. The reason why we got 1 is because we set 1 here. And the reason why I went to 29, class size is 30, I is less than class size. So one other thing I want to point out, just like I showed you here, how could you get in trouble with something inside of the check? So for the check, one way to get in trouble is the use of like less than and less than or equal to, or greater than and greater than or equal to. So let's say, for example, it's absolutely paramount that you print this last number here. The way that you could do that is one of two ways. You can either say less than or equal to, which would then include 30, because remember, 30 equals 30, so it has to be either less than or equal to, or it would have to be 31 and less than. So let's take a look at those two examples. So first, we have less than or equal to. If we run this, you can see that we actually got 30 here. But what if we just said less than and we still needed to print 30? Well, one way we could do that is by taking the variable and adding 1 to it. So we could say plus 1. So now that we said plus 1, let's do the run again. And you can see that we also got 30 with that. So that's just another way, and another way that I want you to think about how you can change the check to match your situation that you need. So finally, let's talk about the control. So just like the check, this can also be a variable as well. So I doesn't have to equal 1. I can also equal class size as well. You can make that change just the same as you could with the check. So in this instance, if I say I is equal to class size and I is less than class size plus 1, that means I is equal to 30, and we're checking to see if I is less than class size plus 1. Do you think this is going to run? Let's take a look. So if I actually go ahead and compile and run it, we get 30. Why did it execute? Well, let's see if we can understand it. So again, since I is equal to 30, and we're now checking if I is less than 31, so since 30 is less than 31, that's why we're able to get this to print. So just another little thing to kind of keep in mind as you're going through for loops. So the final two concepts I want to talk about before wrapping up with for loops is the concepts of break and continue. So let's jot down a couple more notes up here. So break is a way to break out of the loop when you meet a certain criteria. So you can use break anywhere inside of a for loop that you want, and it'll exit that for loop even if I put it, say, right after this print. Let's take a look at exactly what it does. So I'm going to change I back to 0. And we still have class size plus 1, and we still have I++. But let's check out what break does. So I can put break here. So if you're familiar with what break does, you'll know exactly what's about to happen. But for everyone else, let's go ahead and save, and then we're going to compile. And then we're going to run it. And notice that only 0 printed. The reason why is once we hit this break statement, break is saying exit this for loop. We no longer care about any conditions or anything like that. When you resume your code, resume from right after the final curly bracket in the for loop. So that's how break works. Now let's talk about continue. Continue is effectively a skip that you can do inside of a for loop that will skip code after the continue statement. So one way we could do that is simply by, let's erase this break statement. And let's go ahead and put continue before our print, and let's see what happens. So I'm going to write continue, and I'm going to save this, and let's run it and see what happens. So just to clarify, without this continue, what would happen is we would print 1 through 30, and then, 0 through 30, and then we would stop. But now with this continue, let's see what happens. So if I go into here and I compile, looks like I have an error. So let's see. It says unreachable statement. And that is because of the continue. See how I have continue here? Continue is going to act as a blocker for this, and we'll never hit it. So one way that we can use continue is, like, let's say we were looking for a particular number. Let's say we wanted to skip the number 15. So now let's actually use something we learned in the last video with if statements. Let's go ahead and put an if inside of our for loop here. We're going to say if I equals 15, then we're going to want to continue. So with this code that we have here, what do you think is going to happen? Let's find out together. So let's go ahead and save this. And let's go ahead and compile and run. And if we look, we printed out all the numbers, but then 15 is absent. And that's because of continue. Let's try to understand how continue worked in this instance. When we met this condition where if I is equal to 15 and I was equal to 15, we came into our true block for our if statement and we executed continue. So the way continue worked was, once this executes, it says skip everything else inside of the for loop and go back to the top and then continue. So does that make sense how continue works? So basically continue says disregard everything after this and then just go back to the top and continue. That's why it's called continue. So one of the important things to note is usually when you're using continue, you want to trap it so that way it doesn't block code from executing unnecessarily. And so in this instance, I trapped it by saying if I equals 15. You also usually want to do the same thing for like a break statement. So like, let's say, for example, if I equals 15, instead of doing continue, let's do break instead. So now by doing break, what do you think's going to happen after I equals 15? Let's find out. So let's go ahead and go into our command line. We're going to go ahead and compile and run. And look at that. We get all the way to 14 and stop. Now, why didn't we print 15? Because the system.out.print came after the if statement. So since it came after the if statement, that's why it didn't execute. Break kicks you to outside of the for loop and right at line 15. So basically, once this executes right here, you're going to start resuming from 15. So if you notice, and recapping, so break is the way you break out of a loop when you meet a certain criteria. So then continue is go back to the top and continue. That's the difference between break and continue. That's all we're going to cover for for loops for today. There's definitely more things you can do, such as nesting for loops, which we're definitely going to talk about in a little while. And we can also do things with arrays. But right now, if you understand this basic concept of how a for loop works, and you understand the parts that make up the for loop, which is inside of the parentheses here, you're going to go a long way. And that's going to be the end of this lecture today. So I'm going to kick it to me in the future. That concludes this video on for loops. And I got to say,
It'll drive you loopy.
I hope you enjoyed this video. Let's keep rocking. Let's keep learning. Let's get it. Oh. Oh. My head hurts. Anyway, take care. Peace out, everybody.